Okay, I am meant to calculate now a directional derivative of a function of two variables in the direction of some vector at a point. Sorry about this messed up t right there. I forgot to write in the point for a second. Is. So here's what I wrote. The vector here, 4, 3, dotted with the gradient of the function. But then I realized I forgot that vector right there, get out of the way, hand, is not a unit vector, and so I need to, what's called, normalize it. I need to divide by its magnitude, the square root of 4 squared plus 3 squared, in case you can't read it because I'm writing with a big fat pen to try to make everything readable. How ironic. Okay, but that unit vector, this times this, dotted with that gradient, evaluated at 5, 5, will be the directional derivative of this function, the direction of that vector, right? In the direction of this thing actually is a direction. Let's see. That thing right there actually is a direction, right? Multiply the vector by 1 over its length and you get a direction. Okay, let's get to work. This is, let's see, 1 over 4 squared plus 3 squared. That's 16 plus 9 is 25. Oh yeah, there's a 4, 3, 5 triangle, so that's actually just 1/5 of 4, 3 dotted with, now let's take a look at that gradient function there. Okay, the derivative with respect to x of that expression is 2y. Yep. And the derivative with respect to y is 2x minus 6y. That I need to evaluate at 5, 5. And let's see. Before I evaluate at 5, 5, I'll go ahead and do the dot product. I'll have a 1/5. 4 times 2y, that's an 8y. Doing the first part of the dot product. 4 times 2y. And then a 3 times 2x minus 6y. Let's see. That is a 3 times 2x is 6x. And then minus 6 times 3 is 18. Y. Okay, and that guy I am meant to evaluate at the point 5, 5. All right. Hey, wait a minute. Yeah. Okay, so I'm going to replace y with 5, and I'm going to replace x with 5, and I just see that when I do that, the 1/5 and all those 5s are going to cancel, giving me 8 plus 6 minus 18. All right, and let's see. 8 minus 18 is negative 10. 6 minus 10 is negative 4. Okay, so that means that this function right here, I don't know how to draw its graph. Its level surfaces even would be a little bit difficult. But if you move in the direction of the vector 4, 3, starting from the point 5, 5, then the rate of change would be negative 4. That is to say, this function is decreasing as you move in that direction from this point at a rate of 4. Okay, that wasn't too bad.